I will start in English. I mean, you can give questions in German if you want, and in addition, if you during the talk want to give questions, just raise your hand. We can just do it in the talk, so you don't have to wait until the end. This talk is about behavior-driven development. So, first question is, who does not know what behavior-driven development is? Okay, quite a lot. That's interesting. Who did already use behavior-driven development in practice? Okay, 3 or 4 people. Okay, so then maybe after the talk you first will know what behavior-driven development is. There's only a short introduction section about that, but still I think you will have afterwards the knowledge about that. And in addition, you might even introduce it in your Java projects. Because this talk is about behavior-driven development in plain Java. So it's especially useful if you have a project where you are not only using Java. You can also use it for Scala or any other JVM language, but I designed it especially for Java because in Java there were no such framework existing before. So that's the reason for that. Okay, so why do we want to use BDD or behavior-driven development? And somehow during my project, I am still in large Java enterprise project. We wrote, we are doing test-driven development. So we are writing very many, basically JUnit tests. And a typical test looks something like that. So I hope you can read it from the last places. But if don't, it's also not that important. This example is taken from the Spring Pet Clinic example project from Spring. So from the Spring guys, so they know how to write tests, I would guess. And this is quite a typical way of writing tests. You see that there's a description here above, so the name of the test somehow gives you a bit understanding about what the test is about. But then there is much code, and the main problem here is there are some technical stuff in there, like for example, there is a usage of an entity util, and you create objects and so on. And it's, for the first, so there are several problems with this, which I summarized here. The first thing is that such tests are often hard to understand, even for programmers. This test was, I would say, mid-size from the size. There are even larger tests which are even larger. And if you are a developer which, let's say, introduce a new feature, and when for some reason some test fails on your continuous integration server, and then you have to look into this test, which someone else wrote a year ago, then you have to understand, did I actually break that test? Or do I have to adapt the test because now the system behaves differently and I have to adapt the test? So that's something you have to understand as a developer when some test is failing. And the next thing is that these tests contain very many technical details. And this makes it difficult to really understand from the domain level point of view what the test is about. And this is often the important point. From the domain level point of view, you want to know what the test is actually verifying or testing in your system. Which is often also the case, but it depends somehow on the discipline of the developers that these tests often contain code duplication. Because somehow even good developers do not apply the same practices to test code like to production code. This leads to copy and pasting of tests and a lot of code duplication. But finally, the main thing or the main problem is that the tests can only be read by developers and only be understood by developers. So if you're doing test-driven development, it might be that 50% of your time you're writing tests and you have a large test code base, and these tests can only be read by developers and not by the business people who write the requirements or who want to know what the system is doing. So you somehow have wasted much of a potential information because only developers can read it. And the point is that automated tests like this one actually document the behavior. And the nice thing is that the documentation is also verified against the product. However, the documentation cannot be easily read, and only by developers, and even then it's somehow hard to really see what the test is about. Okay, so that's the problem about this approach. And yeah, the solution comes from behavior-driven development. And in behavior-driven development, the point is that you do not only write tests, but you write so-called behavioral specifications. And these behavioral specifications are written in a semi-formal format. And it's, in particular, they use the domain language of the product. And that's important so that business can read these specifications and can tell whether this specification actually makes sense. So you can really give your specifications to a business analyst, for example, or the business analyst can even write these specifications and give it to development, and they can talk about that and see whether the specification actually makes sense. The behavioral specifications are executable like normal tests, so it is ensured that they really test the product, so the product actually behaves like specified. And it's not like some written document, requirements document, which might come out of date after some time. And then you are not sure whether the system actually behaves like specified. Yeah, and important is that this is a vehicle or a mechanism so that developers and business analysts or other stakeholders can collaborate on defining the behavior of the software. So, to sum it up somehow, if you use TDD, you build, the question is, are we building the product right? Then TDD gives you the answer, yes, you're building the product right, but BDD gives you the answer to, are we building the right product? And this is, I would say, another level and an enhancement of TDD, actually. So, BDD in Java, that's the talk about, because there exists already many frameworks for doing behavior-driven development in Java, actually. It exists since over 10 years, something like that. And there's really a large amount of frameworks. And there's especially one framework which is, I would say, currently used the most. And this is Cucumber. Who heard of it already? Okay. This is more or less the state of the art, I would say, of behavior-driven development. It's actually was developed for Ruby, but can also be used for Java and for many other languages. So how does it work? First of all, you write so-called feature files in a format which is called Gherkin. It essentially is something like that. So you have feature files, you define, so it's actually a text file, as you see here. And you write in a text format something like a feature ordering, and then you give a number of scenarios. For example, customers can order books. And you write, given a customer and a book, and 3 items of the book are in stock, when the customer orders the book, then a corresponding order for the customer exists. So it's written in a domain-specific way. You can give this to a business analyst, and he or she can say, no, that's wrong. It should be something different. It's not correct that their order should not exist because there should be first an email sent out or something like that. And that's the important point, that you can use this and collaborate with non-developers on this behavior specification. And afterwards, you even have a specification of your system which forms somehow a documentation of your system, which you can also refer to. If you have a question, what was about this ordering, I can look it up and I see it in my feature files, for example. So, but the problem is, we said that these specifications must be executable. So there must be some mechanism to execute these text files, because the text files on their own, they won't execute. So in Cucumber, you write step implementations in Java, for example, or another language. And they look like that. You give here, you define methods which correspond to your steps. So, for example, a customer method, and here you also have an annotation which says, okay, if the text matches a customer, then execute this method. And you can also have regular expressions, for example, if you want to have parameterized methods like that. And this is the way you link the text files to the execution. Okay, this looks nice on the first side maybe. So why didn't we use it? Actually, we used Cucumber in our project, or someone introduced it because we wanted to have tests which are better readable, and actually we wanted to use behavior-driven development. So some of my colleagues introduced Cucumber. Then he went away for half a year to a sabbatical. Then he came back, and in the meantime, no developer ever wrote such a test. Really nobody. And that's really the problem about Cucumber, because Cucumber introduces a high maintenance overhead, which is higher than if you just would write your tests in your code. So if someone at the end of a sprint, maybe you have to write some tests, then the developer will not use Cucumber because it just takes too much time to write the test. He or she will then just write the standard unit tests. So the acceptance of this framework is actually very low, and I myself even wouldn't like to use it. Because if these feature files grow and grow up, and let's say you have thousands of these feature files, then it becomes really a maintenance hell. Because if you want to refactor something, change some text or something else, you must adapt the corresponding step definitions. And it might be that you change something and suddenly some regular expression hits you which you didn't expect, and so on. So you must keep this code in sync. If you read, then hear some people of Cucumber, they say that feature files are never changed. They are just they are once defined, and afterwards you never change them because it's now a fixed behavior of the system. But in practice, I would say it's not true, because if you introduce a new feature, it might be that it affects another feature. So it might be that you have to change the behavior, or you have to change feature files. So you have to maintain these files. And if you already do test-driven development, and already half of your time you're spending writing tests, and then you have additional maintenance cost of maintaining these files, I would say you will not do it, or it will hurt you at some point. And that was the reason why we didn't use it, or we thought about using something else. Another problem is you cannot use your programming language in this feature file, so you have to hard code the text in this feature files. You cannot use any for expression or loops or whatever. You just have to write it as it is there. And you have limited IDE support. There are plugins for that for sure, which can help you, but it's not that good as if you just used your Java IDE. For example, refactoring as an example. So what I said already more or less, problem is that developers do not like it really, I would say. I mean, there might be developers who like it. I wouldn't say that this is not the case, but most of the developers, I think, will not like to use it if they are not forced to use it. And another point is about these feature files, why they were introduced, is that it is possible for a business analyst to write these files directly. So this is maybe an advantage of Cucumber. A business analyst could write these files. But in practice, we also see that this really rarely happens. A business analyst doesn't want to write these files. And in addition, even if someone would write these files, the development team would still have to maintain these files at the end. So this is an advantage of Cucumber, which I would say, we at least didn't require that feature. So what about other frameworks in the Java world? There are quite a lot of them. For example, JBehave. This was even before Cucumber. It has the same mechanism. There's plain text plus Java files. And there's Concordion, for example. It uses HTML and for writing these specifications, and then you write Java code to bind the HTML files to your Java code. Then there's Fitness, which is similar, which uses a wiki system. And so I would say these are the classical tools. And then there are some more developer-friendly tools for writing behavioral-driven development. For example, very famous is Spock, I think. Spock is based on Groovy. and there you can write some behavior-driven like tests. Then there are Scala tests, which uses Scala, and Scenario, which uses extend. But there is actually no framework I know of which has enough features which I need, which is actually written in Java. So if you cannot use Groovy, then you cannot use Spock, for example. So what are you doing then? So yeah, I wanted a developer-friendly BDD framework for Java. And OK, let's try to ask Stack Overflow, what about that? And there is actually an answer about that. It looks like this. I hope you can see it from the end. It essentially, I mean, it also mentions all the other frameworks, which there are. But then the suggestion was, yeah, then write comments in your tests, and then you have something like behavior-driven development. OK, but I must admit, as I would say, clean developer, I would not write something like that, because I would immediately try to refactor that away to some method call, which is named accordingly. So this was not an option. And also, what I really found interesting is the last sentence. I read it for you. I also think that the most successful BDD frameworks for Java are those that are written not in Java, as Java language has no such flexibility for DSL creation as Groovy or Scala has. Okay, this was then the point where I really was interested in writing such a framework. So yeah. So that's when JGiven was born, I would say. At that time, it wasn't called like that. But I just wanted a framework to have readable tests and especially also maintainable tests, which allows you to reuse code. Because that was, at that time, also a problem in our project, that much test code was duplicated, or different things have been done on different places the same time over and over again. And I wanted to solve two problems actually, that I was able as a developer to just read the tests, and they should be in the domain-driven in the domain language, and the technical details I want to have hidden. And I wanted to have a framework which allows me to reuse stuff which I require in my tests. So that's JGiven. So that's the scenario written in JGiven. And what you see here is a standard JUnit test, actually. So that's the JUnit annotation. You can use it also with TestNG. It's also possible. And then you see here the scenario. And it's completely written as the scenario you have seen before. It's in a readable domain language. It uses a Fluent API. And as a developer, you can immediately read it, because you can ignore these parentheses. As a Java developer, you don't see them anymore anyway, so it's fine. And that's actually it. So you write your scenarios in plain Java, as I said. And you see that it's written in Snake. Everything is written in Snake case, which might be important for someone. The point is, so it's important for JGiven because with Snake case, you can really write your text in the correct casing. So if you have something like HTML, you can really write HTML here out. And JGiven is then able to generate reports which are really in the correct casing. So that's important. In practice, it's not a problem to mix Snake case and camel case. So we have this in our project. So if you think that's a problem, typically it's even helpful because you immediately can distinguish between these step methods here of the scenario and other technical methods which you don't want to have in your scenario. So it's actually helpful, I would say. And it also helps reading because actually Snake case is better readable than camel case. OK, so that's it. Some facts about JGiven. You write your scenarios in a domain-specific Fluent API. It works with JUnit and TestNG. And also it tries to minimize the annotation overhead, which you have to do. So you really can just write your source code, and JGiven tries to derive everything from your code. So you don't have to add additional annotations. Something which you had in Cucumber, you had the step definition as a method, and then in addition you had to write this matching text, for example. And yeah, this also minimizes the maintenance overhead of this. Okay, but what about the non-developers? I mean, you could give something like that. Yeah.
I think you want to check whether we are still alive or awake after lunch, because that phrase, a corresponding order exists, for instance, that you had one slide before this, please, yeah? The last one, a corresponding order exists. How does the system map this to the actual Java code that you have in your
good question. I come to that later. Okay. For sure, there is some hidden implementation here, but it's not shown on the scenario test here. So it's more or less, you can see it as an abstraction layer over your normal test code, which helps you to create better readable tests. So you are more or less enforced to write readable tests. You also get code reuse, which I will show later, because you have this definition, the implementation of, for example, a customer somewhere stored, and everybody can just use it by calling a customer, and it's immediately there. But the implementation is hidden behind these methods. Okay? So this is nice so far for developers, but as I said, we actually want to give something to the business analysts to talk about. And yeah, that's what JGiven does. It generates reports, and these reports can be given to the business analysts or to business guys. And there you can show them the reports, and you can talk about them. And yeah. And yeah, first report is a plain text report, which actually just prints out what you have seen before, just on the command line, and exactly more or less looks like what you would have written in Cucumber in the first place. But you don't have to write it because it's generated for you. It doesn't cost you anything. And then there is HTML report, which I want to show you. So I hope the problem is a bit that, okay, it works. That the resolution is very low here on this beamer, so you only see the mobile version, actually. But that's how the report actually looks like. The HTML report, you have your scenarios, and you can click through them. You can also have tags here. For example, if you have features like the feature order, you have tags. You can click on the tags, and then you get a list of all the scenarios that belong to that feature. Often you have also tags like story numbers or issue numbers or something like that, so that you can organize your scenarios by that. Okay, so let's come back to talk. And if you're curious, there's also a JGiven report of JGiven itself. So you can look this up in the internet under jgiven.org. Yeah, there you see the specification, so to say, of JGiven itself. So let's compare classical BDD version versus JGiven. In classical BDD, you have to write somehow readable text, and you have to write the code, which executes the tests, the text. And in JGiven, you actually only have to write readable code, and you get generated the readable report. So this really is much less work than the other approach. So experience from practice. So what we experience really is that, yeah, we use it for over a year now in a very large enterprise Java project. We have written over 1,300 scenarios already, and it's really improves the readability and code reuse of our tests, and it makes it even easier to write tests than before. So it actually reduces the maintenance cost of our test suite instead of making it more expensive. However, that's just a feeling more or less. I cannot provide you with hard numbers, but I myself, I really like it much more to write now tests in the framework than before. And I also, from what I heard here from developers, often you have to stop them writing tests because it's so easy. because tests always have another cost because they have to be executed, and yeah, so. But the maintenance cost is really low, and it's widely accepted by developers. So it was not very difficult to get the developers using it. This was one main point, because I didn't want to have another framework which we introduce and nobody uses it. I want to be sure that the framework is really used by the developers, and this was the main important point. And it's also easy to learn by new developers. So if a new developer comes into our project after a week or so, he or she can then is able to write this. I would say, features, writing scenarios with existing implementations and steps already can nearly be done by everybody. But if you have to implement steps, then you need a bit more experience. And we also use the reports, actually, which we generate and show them to the product owner or the business analyst. In fact, it's working like that in our project, that the business analysts write acceptance criteria in a Jira system. So we have a story and there are acceptance criteria. Then the developers translate these acceptance criteria into JGiven scenarios. And at the end, we can compare what the report shows you with the acceptance criteria, what the business analysts have written. So, and the business analysts use the same format. They write these scenarios also in the given, when, then format. Okay. Any questions so far?
Yeah. To this slide, do you know about acceptance outside of TNG?
So it's on GitHub, and currently it has 30 stars. So you can download it, you can use it. I mean, it's not that widely known yet. So, but it's used outside, yes, also.
It's gaining some traction.
Yeah, I hope so. Yeah. And I hope I can convince you that's really useful. Okay, any other? Yeah.
I tested.
You tested?
I tested.
Yeah, great, cool. Okay, then I will give you getting started. Actually, I would like to program now. The first thing is, which I already did, is if you want to use it, you have to add the JGiven dependency to your project. It's hosted on the Maven Central, so you can either use the JGiven JUnit artifact or the TestNG version. Works also. They are used the same, so I will only show you the JUnit variant. Okay, so let's try. So this is this bookstore example, which I've shown you the example before. And the first thing is you have to create a test class. And I will switch to presentation mode. Okay, and yeah, what you have to do, the first thing is to extend from scenario test. That's a predefined class from JUnit. You can also implement it if you are forced to inherit extending another test class because of some historical reasons. You can also try to copy the code from these, because essentially JGiven is implemented by two rules, JUnit rules, so the class rule and a normal rule. So you're not enforced to extend from it, but typically you would extend from the scenario test class. The next thing is that you have to provide 3 type parameters. And these type parameters, I will explain them later, represent so-called stages or stage classes. And these classes contain the implementation of your steps. They are 3 type parameters because for every of the, as you know, we write your scenarios in given, when, then notation. For each of these stages, there is one class. Because typically you organize the given steps in a given stage, the when steps in the when stage, and so on. This makes it later very reusable because you can then use one given stage and combine it with another when stage, for example. So we use 3 stages here. And my when stage. And now you just write a standard JUnit test. So you add your test annotation. And the first important thing is the name of the test method is already important because that is already parsed by JGiven to generate the title of the scenario. So this you should give it a useful name. I know my first scenario should work maybe. Important here is again that you have to use snake case, as I said, and then you can just start by writing given. And then you get a list of methods of your given stage. You can configure your IDE to ignore these to filter out these standard methods here. But yeah, as you see here, I have two methods here to choose from, which is, for example, some pre-state. And I also want some other state, let's say. So as you have seen, the IDE already provides you everything with auto-completion and so on. So it's really, really fast if you have already implemented everything if you have already implemented the step methods to start writing your scenario. And this is also typically the case. Most of the stuff is already there. You only have to, for your new feature, maybe write a new action or maybe write a new validation method. But 80% or so of your scenario is already implemented. You can just use it. And at the end, you write something like that. And then your first scenario is actually finished. And you can just execute it like a normal JUnit test. I think I have to, OK. Yeah, actually, this is an example where one of the step methods actually fail. OK, I think I have to make this a bit. So you see already here that there is the output, which is print on the command line. We can see that at the end. Is it large enough? There you see it prints out what I have written here. As the action currently fails, because it throws an illegal argument exception, it marks this step as failed, but continues execution and shows the next one that has skipped. So see here. We can change that here to maybe do nothing, and then re-execute it. And it's green and it works. And you see the scenario is executed. And that's actually it. So you have written your first scenario. So it's really very fast. And if you have already implemented the stage classes. The stage classes are already very simple. You can, here again, you can use IDE features to just jump to the implementation. You are already there. A stage class looks very simple, but I will explain the details later. Essentially, it just inherits from the predefined stage class. Then you define your methods, and inside you have your implementation. And there is also some special stuff which I now explain. So any questions regarding that? So you've seen, if you already use JUnit, you just have to add the dependency, extend from another class. You can immediately start using JGiven. Yeah.
So I have to encapsulate all my methods in a test method. Or
yep. Yeah. So the test method is the scenario, and inside it there are the steps of the scenario. Okay, this is just summarizing what I just made. And now we are writing the stage classes. So what about these stage classes? They are somehow special in JGiven. And I also think they are more or less a unique feature. And they really provide the modularity which you gain and the code reuse. And yeah, this is also experience from our practice that it's really useful, a really useful feature. So what are stage classes? So yeah, that's actually what I said already. So in a summary, stage classes are very useful. So, but how do they work? The point is that a test typically consists of three of these phases, actually nearly every test. You have some code which prepares the state. And then you have some code which does some action. but typically this action requires some state from the previous steps. And the action typically then creates a result, and at the end, the assertion requires some information of the previous state. It requires also the resulting state to do this assertion. And that's actually the problem with which you face when you want to write reusable tests, that you have to transfer these states between the different methods. And that's solved in JGiven with a certain mechanism, which is called state transfer. And it's made possible by annotating fields of a stage class with @scenario state. And if you annotate such a field, then the state is transferred between the stages. So you can have a given stage where you provide some state, and in the when stage, you can then write expected scenario state, and you get the state transferred to this stage. And important is the stage itself must not need not to know each other. They can just say what they want to have, and you have to plug in some stage which exactly provides what you want. And so you can really modularly define your scenarios. So here's an example. You have the myGiven stage, which wants to provide a state. In this case, it's just an int variable. You annotate it with provided scenario state, and the when stage has the same field here, but annotated with expected scenario state. And then this state is transferred here to this variable, and the stage class can also have an output again, which it provides to the next stage to do the assertion. Okay, any questions to that? Yeah.
So the matching is done by the name, right? So field names to get it over to the next one.
So actually you can have both. By default, if it's a standard Java type like int or some Java util or Java lang type, it just uses the name of the variable. If it's a type of your own, it uses the type.
Okay.
If you want to use the other resolution, you can have here, the annotation has a resolution attribute where you can specify that you can use the name resolution again.
Can you also specify that you want to use a different name? So for example, you have a given stage where it's one name and a when stage where it's another name, and you want to match them somehow. Is it possible? Or?
Okay, the question was, because for the video I have to repeat the question. The question was whether I can define another name. No, that's not possible at the moment, but nothing prevents you from writing it. No, but okay, you can. Maybe it's not, if you really need it and you think it's a nice feature in practice, we can implement it. It's not that difficult. But currently, it must be the same name. And also, we hadn't any use case yet where this hasn't been enough. But it might be that other users would require that for sure. Okay. Then we get to another important feature. So this was just the basic stuff. But if you look at Cucumber, for example, you can have data tables and other nice features. And you can also have this in JGiven. Because it's very important that you don't have to write for each of your scenarios your own scenario again. Often you have parameterized scenarios which are data-driven. So you provide a set of data, and then you execute the scenario against different values. And you can do this in JGiven with data-driven scenarios. First thing is what you need to do, what you require is parameters and step methods. So if you have a step method, because so far all step methods didn't have any parameters, but if you want to have parameterization, the step methods also must have parameters. And you can write something like that, a customer with name John. In the report, it will just print out John here, so nothing surprising. But what if you want a parameter in the middle of the sentence? Something like there are 5 coffees left. That's also possible in JGiven. You just use the dollar for that. You write something like that. There are $coffees left. Then you have the parameter, and JGiven will then fill out the dollar with the parameter. So you can have, at arbitrary places of your sentence, you can have parameters. Okay, now we want to have really parameterized scenarios. And how do you do that? First, in JUnit, you have to choose some framework which provides you with parameters. In JUnit, there are different possibilities. Or you just use TestNG, which has it already built in, more or less. In JUnit, there is the parameterized runner, and you can also use theories. But what we typically use is our own written data provider runner, which is also from TNG, which I can really recommend. And here it's as follows. You have the normal test method. You write an annotation here with the data you want to provide, and you have multiple parameters here in the test. And when you execute it, it will actually execute the test 3 times with the different parameters. And your scenario just looks as before. You just pass in these parameters where you need them. OK, what happens in the report is the following. JGiven will actually generate a table here with all the different parameters and fill out in the scenario placeholders, which indicate where the values are actually have to be. And this is also nearly like, it's exactly the same like you would write in Cucumber in a text form, but this is generated for you. And in the HTML report, we might have a look at that too. Yeah, it creates a nice HTML table. So we're going to go back. Yeah, another nice feature is derived parameters, because sometimes you only want to provide one parameter, but another parameter can just be derived because you know, okay, this parameter is always one less than the other, and maybe you don't want to write this here down. You can do this in JGiven. It will generate another parameter here, because JGiven actually doesn't matter what you pass in, which parameters you pass in. It tries to find it out after you have executed which parts are actually parameters, and they are extracted and filled in here. If you wonder where the name of this placeholder comes from, it's actually the parameter name of this step method. So this is also something which JGiven does. It parses everything of your code, and everything which you write in your code might influence your report. So that's reduces the number of things you have to write. OK. You can also do something like this, even though I don't really suggest it to do, but you can do it. You can have if-else statements here inside, which I told you, which is not possible in Cucumber because you only have text. But you could do something like this. And what happens in the report, this stuff is not shown in the report, but what you now essentially did is you generated 2 different scenarios with this test. And yeah, JGiven will give you 2 different scenarios, one with the one method and one with the other method. But you now cannot have the nice data table anymore because they are structurally different, so I cannot just fill out the fields. So it's something you maybe sometimes want, but in general, you should try to avoid that. OK. Still some time left. It's nice. Then I can quickly skip over some additional features if there are no questions in the meantime. OK. So you can format your parameters, because if you pass a parameter to a step method, by default it just uses more or less the toString method of the parameter. Sometimes you want to have something different. A good example is a date object. You pass in a date object and you want to have it formatted in a certain way. Then you can use additional annotations to provide custom formatters, or you can even define your own custom annotations to do so. Here's an example, an on-off formatter, and it uses the Boolean formatter. So actually, it is possible to format Booleans. And then you can write something like this. The machine is $, on or off. Provide you give it a parameter true, for example, or false, this case. And in the report, it will replace this with off, because you used the on-off formatter there. You can also have tables as parameters. Sometimes this is useful. There are different ways of doing it. For example, if you want to pass an array, then you can use the add table annotation. And the code here doesn't look that nice anymore because you have to create an array, but as before, you are in a full programming language, you can just have a method which generates this array. It must not be explicitly written here. If you execute it, it will generate you a report with this table here, which is nice looking. So yeah, but you can also have a list of POJOs, for example, as a table, or even a single POJO, which is also then formatted as a table. Then there are lifecycle methods in stage class. Yeah. Yeah. I'm sorry, I'm just skipping a bit over these features because there's not much time left.
Yeah, okay.
But yeah, this is maybe important. You can, in your stage classes, you can have lifecycle methods. For example, you want to have something that happens before every scenario, like creating a temporary folder or something like that. Something which you know from JUnit already, you can also use in your stage classes. You can, so this would ensure that this method will be executed before the scenario and this method will be executed after the scenario. You can also have something like JUnit rules called scenario rules, which do the same essentially, but encapsulated in a class. And more important is maybe the before and after stage annotations, which allows you to have hooks within your scenario. So for example, after your given stage has finished and before the first when step happens, then the after stage method is executed. We use this very often, for example, to use builders inside a stage class to build up some state, and at the end of the given stage, we can then persist it to the database, for example. So that it's then available for the next step. As I said, you can have tags. Tags are essentially just annotations with some special tag on it. And these tags will appear in the report. So you can organize your scenarios with tags. Tags can have values like that. There is a not implemented yet annotation, which you can put on scenarios when you want to write the scenarios beforehand, and you know that they are not finished yet. Then they will already appear in the report, but they will not be really executed. But you see already in the report, there are still 10 scenarios which have to be implemented, for example, which is sometimes nice. Yeah, there is a hidden annotation. If you have, sometimes it's necessary, a technical step in your scenario, and you have to write it somehow there, but you don't want to have it appear in the report, you can hide it. You can give steps additional descriptions or extended descriptions. Sometimes useful if you want to describe what a certain step is in more detail, you can add this annotation, and in the report you can then have a tooltip for that. And you can also have attachments in your steps. They will appear here as a little icon where you can click on, and you can have, for example, screenshots. If you do a Selenium test or something like that and want to have screenshots in your report, you can add these annotations also to the report. Okay, so that's it so far. Conclusion. So why do I think JGiven is useful, or why should you use it or try it out at least? So first, it's developer friendly. That was my most important goal when writing the framework. I wanted to use it, and I don't want to have some obstacles which I have to use, but which does not help me really as a developer. It provides you with a high reuse of test code due to these stage classes and the modularity of the scenarios. It's just plain Java. You don't need any other language for that. You could use it in Groovy if you want, or you could use it in Scala, but you can also use it in Java, plain Java. And that's the main important thing, was for me. Because in our project, we could only use Java, so I required that. It's very easy to learn, in my opinion, and experience also shows it in our project that everybody in our team can use it. It's very easy to integrate into existing testing infrastructures. You can just use the JUnit. If you already use JUnit, you can immediately use it. And you get, in addition to the report which is generated, you also have the JUnit results. So You have then both reports which you can use. And it's readable for non-developers, for example, business analysts. And yeah, we also really use it in practice. So we show it to our product owner and our analysts. They look at it and compare it to what they have expected. Yeah, and so to sum up, it's BDD without the hassle. What are the things which are not so nice or which are not possible? And one thing, it's I think the only thing, is that non-developers cannot directly write executable scenarios. So a business analyst cannot write these scenarios if he or she does not know Java. Okay, that's the only thing which is not possible. But I would say there are two buts. The first thing is that the business analyst can still write these scenarios in plain text or in Word or whatever, give it to the developer, and the developer can translate it very easily to Java code. And afterwards, it's there, and then you can discuss with the business analyst about that. And also in practice, as I said before, it rarely happens that non-developers really write also these Cucumber feature files. And the generated reports can then be given to business analysts or the product owner and can be shown by to them. They can validate it. Yeah, that's it. So if you want to know more about JGiven, you can visit the website. There is a GitHub repository for that. So if you have any issues or comments or pull requests or whatever, that's the place to do it. And yeah, otherwise, thank you for coming. And yeah, if there are any questions, happy to answer them.
Are the reports just reviewed, or is there an interaction going forward and backward, you changing the reports as a new kind of requirement?
Yeah, typically they are reviewed at the end of the sprint, and then the product owner or the business analyst look over these acceptance criteria and say, yeah, there is something missing, or maybe you can write additional scenario which covers the other case, and so on. So there is really a discussion at the end, and this is then adapted by the developers again. Sorry?
Is there a way to pass data back, so from the document somehow to the code?
Okay, the question was if it's possible to pass data back. No, it's not possible. It just generates a report, and that's it.
It was actually the same question. That is, I think you could generate an editable report, and then it also answers the column somehow, and then you allow the business analyst to immediately maybe feed back the.
Yeah, sure, that might be possible really, and I already thought about something like that, so maybe in the future there will be something like that, but currently, yeah, it's not. I think you was?
I had basically.
Okay. Yeah.
At which level would you recommend to write JGiven tests? So I'm thinking of a Java application which has a JavaScript front end, which is connected via REST APIs. Where would you insert your JGiven tests?
Okay, so the question was at which level of my tests I would use JGiven. Actually, in our project, we now even sometimes use it for unit tests on the unit test level. But I would suggest it's on the component level you can use it. It might be that the scenarios then get a bit technical, but in my opinion, it's also not a problem that parts of your scenarios are technical. You don't have to show them to business, but it's useful for the developers in any way. So to because of the reuse thing and the clean scenario testing. So it's even if the test becomes more technical, it's still helpful. And then you have the other part of the test, which are really written in a high-level way, for example, using Selenium or something like that, which you then also show to your.
So even for Selenium tests, you.
Sure. Yeah. Definitely. So that's the perfect fit, I would say. It's Selenium. It's the complete outside. That's clear. But it would also suggest it on any other level. Maybe if you really only test one method of a class as a unit test, it makes no sense anymore. But
when did I get you right? We try to keep our like REST APIs. So would you recommend to write JGiven tests for the REST APIs? So
Okay. Yeah. So the question was if it's useful to use against the REST API. Yes, definitely. So you should do that because you can then write the scenarios in your business language, which tests the REST API from a business level perspective, which is typically what you want. So you can really use it on every level. You don't have to write GUI tests with this framework only that because it's like the user uses the product. You can use it really on every level of your product. And we use it like that. So we also write GUI tests for that, but we use it nearly on every level, even on component level. Only for very small unit tests we don't use it. I think he was first.
Yeah, I wanted to ask what's the lower level where you stop using it?
Yeah, I mean, you see that typically you write 3 stage classes for your scenario. You can do it in JGiven that you only have 1 stage class. There's also so-called simple scenario test where everything is in 1 stage class. But still, I would say if you are on a method level basis and testing some logic of a single method with a unit test, I typically would not use it. Then the overhead is then too much, but the overhead is so less that you can even use it on the component level. Yeah.
Did you experience any problems with mocking frameworks or something like that is fully compatible? Or
Yeah, so the question was if it's compatible with mocking frameworks. So yeah, JGiven is just actually a very small framework which allows you to use anything you know from JUnit. So you can use any mocking framework, you can use any assertion framework. It doesn't provide you or restricts you to anything. It's different to Spock, for example, where you have the built-in mocking and so on. And if you use this framework, you just use it to write your scenarios. What you do in your stage classes is essentially the same what you do in your normal JUnit tests, using any mocking framework or assertion framework, what you want. Yeah. Ben?
I think, yeah.
Thanks.